Okay, so welcome everyone to the final preparation class. Um, um, so earlier today, I posted the question for the midterm and the makeup midterm, and maybe it would be a good idea to start there. So let me just do that. And so what I kind of don't want you to do is to the last lecture, which covered the hydrogen atom, was I'm not going to actually give you any question in the final from there because we didn't spend enough time on it. So, but that doesn't mean that there won't be anything that is not related to that. Okay, so this is the midterm that you saw, and so, obviously there will be some question from the harmonic oscillator. Well, not all four, but there'll be at least one question from the harmonic oscillator. It could even be two. And then I also wanted to so this is something that most of you haven't seen because most of you took the first midterm. And as you can see in the second midterm, we have a question which is almost identical to one of the questions from the first midterm. And now there's also this question from the Heisenberg operator, was there a question in the first midterm on the Heisenberg operator? Let's see. No. So that's something that to look out for. So this is um, this question on the Heisenberg operator. And it's actually kind of very easy to do, although it looks kind of forbidding because you have to use. But let me just read this question. Recall that this is the definition of the Heisenberg operator. Sorry, this is the definition of the Heisenberg operator. If O is the Schrodinger operator, and then using the BCH formula, you have to express AH and AH dagger in terms of A and A dagger for the harmonic oscillator, right? So, so you have to think in terms of you. Let me just do this question. Um, um, give you some hints. Okay, there seems to be a comment. কুইজের টাইম হচ্ছে 5টার পরে হবে I'll announce that 5 p.m. or 5:30 p.m. I think তোমাদের পরীক্ষা কখন শেষ হবে 4 তাহলে let's do 5 then um, কারো কি আরো আছে পরীক্ষা যেটা 4টার পরে হবে okay I'm sure not everybody's sorry
আমাদের হচ্ছে পরের দিন আরেকটা এক্সাম আছে তো ম্যাথের, তো একটু যদি আগে নেওয়া যেত ভালো হতো, মানে চ্যাপ্টার চাপ করাটা সাহায্য হয়।
4:30 জানতে আমার তো 4:30 নিতে কোনো অসুবিধা নেই তোমাদের যদি কোনো অসুবিধা না থাকে okay okay so we'll go for 7 for 4:30 and okay so so just I just want to outline something. So you're given this operator, say A of H, and the one with the dagger will be similar, which is given by U T dagger acting on the Schrodinger operator, which is just the usual operator, and then u of t, right? So one thing to note is that all the commutation relationship you had before, for example, a of h dagger, so these now will have some time, and we take the time to be the same time. That's important, at least in general. So, what would this be, right? This would be essentially some u, t, a, u, so there'll be a dagger here, u of t, u dagger of t, a dagger, u, t, right? And now if you expand this, then you get u dagger t, a, u, t, and then u dagger t, a dagger, u, t, minus the same term, but with the a and a dagger switched around, right? So here you see that since these are unitary operators, this is equal to 1. So in the end, what you are going to get is u of t, the commutator of a and a dagger, and u of t. And this, is 1. And therefore, you'll get u dagger of t, u of t, which is 1. So you see that the commutation relationship between a and a dagger and similarly a's, they remain unchanged, right? Similarly, n h of t is actually n of n, just n. And the reason is that what is u dagger u of t is, well, u of t is exponential of minus I by h bar Hamiltonian times t. But the Hamiltonian h is n plus half h bar omega. So this becomes exponential of minus I by h bar n h bar omega t plus a constant. Constant, which of course it does depend on time, but it's a phase factor, right? So times a phase factor, which is I something something t. So the idea now is that since n commutes with itself, n h of t, which is u dagger n of u, like this now commute. So we will get just n, right? So n doesn't change. So then you can, if you just compute, now we know that, so these things also don't change. N of h before, a of h was minus a. Now you just put an h. These things don't change either. But anyway, what is important actually is that to find out a of h, we have to use the BCH formula. So the BCH formula tells us we have e to the power minus I h of t. I'm just putting h bar, all this other stuff to say 1. Or I just write this n, a, and then e minus n of t, right? I'm putting, so for example, well, there's a omega equals to 1. But actually, let's not put omega equals to 1. Let's keep omega. Right. So here, the BCH formula is going to be 1 plus I omega t n comma a, right? And then we're going to have I omega t whole squared by factorial 2 n comma a, right? and higher order term. Now here you see this will just become minus a. Here this will become minus a, and so when we take the commutation with this will remain minus. This will plus a, right? So we see that we are going to just get a term where it'll be a one plus stuff, and you should be able to evaluate this easily. Okay, it just actually becomes e to the power minus or plus. I forget, but it becomes something like this, right? So that's how you compute these, right? So it's not very difficult, right, using the BCH. And once you've done that, the rest of the formula follows. All right, so that's basically was one of the, let me unshare this so I can go back to the questions. Are there any questions, by the way, from this? Mm. All right, so there doesn't seem to be a question, so let's move to the. All right, so the important thing is that you don't have to worry about the last lecture. I mean, you want to listen to the last lecture to get the last assignment, but it won't be part of the exam, okay? All right, so let's keep, or just, okay, yeah,
স্যার
বলো।
লাস্ট হচ্ছে সবাইকে আরেকটু আমি বুঝতে পারিনি যা
লাস্ট সরি কি আবার কোশ্চেনটা করো।
আপনি আপনি বললেন যে লাস্ট লেকচারে হাইড্রোজেন অ্যাটম সম্পর্কে যেগুলো পড়িয়েছিলেন সেটা রিলেটেড কোয়েশ্চেন্স আসবে, কিন্তু মানে ওটার ওটা
না,
থেকে
ওখান থেকে কোনো কোশ্চেন আসবে রিলেটেড না, মানে আগে যেগুলি ইউজ করছি ওগুলি আসবে, ওখান থেকে কোনো কোয়েশ্চেন আসবে না, মানে রিলেটেড ইন দ্য সেন্স দ্যাট যে এর আগে যে আমরা ওই যে রোটেশন অপারেটর করছি, অ্যাঙ্গুলার মোমেন্টাম অপারেটর, ওইগুলি রিলেটেড তো, ঠিক না? ওইভাবে আমি বলতেছি, সরি। সো don't worry about the last online lecture, ঠিক আছে? আচ্ছা, Fahim is asking a question, which is, let's see. Oh, I think I accidentally, okay, well, Zoom is very confusing. Okay. Does that mean the contents of assignment 5 are not required as well? Okay, what is assignment 5? Can we have a look? Well, yeah, so that's not assignment 5. Okay, some of you asked for the link for assignment 1. Well, the assignment 1 submission deadline is long past. And since I'm going to do N-1, if you haven't submitted assignment 1, I think just don't worry about it. Just do the others, okay? Okay. Right. So, I mean, this is from the last lecture, right? But this is not from the last lecture. This is actually part of earlier stuff, right? So, stuff related to this might be examinable, okay? The quiz syllabus is the same as this. Just প্রথম থেকে শেষ পর্যন্ত. If you, yeah, so আমরা একটা কাজ করতে পারি. No, it's fine, yeah. The quiz syllabus is from first until my last lecture, excluding the last lecture, okay? And এর আগের দুইটা quiz থেকে হয়তো, although I didn't give it back to, I think I solved them in class, so it's fine. Okay. Um, so I think that probably answers one of the questions. So let me go back to the rest of. And then here is a problem, which is basically something that we did in class, but here it's done in components. So if you're given the fundamental commutation relationship, then you can show the angular momentum relationships, right? And the reason why I did this for this exam is because if you do this in general, then you get a Kronecker delta function on the right, but to get this relationship in terms of indices, you have to use an epsilon tensor. And because of the epsilon tensor, you have to use this identity, and that identity kind of messes things up for some people. So I thought that, maybe just do the simple thing, right? So you might want, so something like this might be in the exam. And question 3b is basically you have a 2 by 2 matrix, and it's an orthogonal matrix, but you're asked to find the eigenvector and the eigenvectors. And here's a hint where R, saying that R is not Hermitian. What is the hint? That means that its eigenvalues will not be necessarily real, right? And in fact, when you diagonalize it, you find that the diagonal form of this vector, you cannot really diagonalize it over the reals. So the diagonal form of this vector, you get some exponential I phi and exponential E minus I phi, right? Those are the eigenvalues. So this is actually becomes a unitary diagonal unitary matrix. And then this one is important because there will be one question, at least one question, that asks you to derive eigenvalues and eigenvector, because this is quantum 2. Eigenvalues and eigenvectors are something you should have learned how to do in either quantum 1 or even before. So we are going to ask you about this. And related to that might be something from the Heisenberg uncertainty principle, okay, which is from the problem set 2. Okay, so let's see. So my so yeah, I mean, practice these two, and then of course the and then we basically look at the problem set 1, and then problem set 2. Okay, so problem set 2, I mean, this is more of a proof. I don't really care so much about proofs. So these are, I mean, so from basically number 5 onwards, what I'm trying to do is that I'm trying to show you how to think about the Euler theorem, right? But this is not really something that is obvious that it can come from an exam. But of course, number 4 is something that can be, number 3 is already, and number 1 is also good to practice, okay? So let's look at the assignments and see what we can, what kind of questions. So, the first assignment, of course, there's some harmonic oscillator. Yeah, so this is a nice problem. Then assignment 2 is propagator. Well, propagator is nice, but it's not something that I think is important for exam, because you already know. So, so there will be problems involving the these kind of operators, the angular momentum operators. And they will be conceptual in nature. They won't be computationally very intense. So they'll be conceptual in nature. Okay. So I want you to kind of understand these operators a little bit better. rather than, rather than, for example, this one, how the LZ operator comes, um, rather than something that is a very difficult calculation. So I don't think there will be like calculations in the final exam which are very difficult, right? So let me just like remind myself what I put in the final, so I can. By the way, I just finished making your final, so I have to know. Yeah, there will be harmonic oscillator and rotation operator, and then Heisenberg uncertainty principle, stuff like that. Okay? So, all right. So, any questions? So, some of the problem set one regarding the uncertainty principles are quite involved in their working. Should we consider looking at those? Let's see. Problem set one. Um, right, that was the uncertainty principle. That was a very, very general proof, right? So let me share this. From problem set one, and so you're saying that this is, yeah, this is quite, this is a long proof. I don't think it's very hard, but it's a long proof that has many parts and blah blah. So what is more appropriate for the exam is something like this. Like I will give you some operators and some states, and you will be asked to, compute the uncertainty. Rather, I don't usually give proofs in in exams, right? I give you problems. So as you can see from, like, although this proof is long, this problem is actually short, right? So, okay, does that help? Okay, any more questions? Assignment 5. When is the deadline for assignment 5? Let's look at the deadline. It was 19th. The thing is that take 1 day more or something, but I don't want to give you more days because, it's really Shafin who is grading all this, and yeah, 1 day is fine, but don't take 2 because Shafin is working very hard to finish. Like MNS is, don't quote me on this, but the university is working these kids to their death, right? So they are really under a lot of pressure. I really feel bad for them. So, yeah. Okay, so any other questions? I think this is good. Any other questions?
Sir, quiz syllabus একটু আবার একটু বলবেন প্লিজ।
কুইজ সিলেবাস হচ্ছে লাস্ট এটা থাকবে না, এই যে লাস্ট লেকচারটা থাকবে না, তাছাড়া সবকিছু থাকবে, ঠিক আছে? Okay. Anyone else?
স্যার তাহলে হচ্ছে লেকচার নোট 5 এর হচ্ছে সেই স্ফেরিক্যাল হারমোনিক্স পর্যন্ত সিলেবাস থাকছে তাহলে।
হ্যাঁ, তোমার জন্য আলাদা একটা স্পেশাল কোশ্চেন আমি করতেছি, তোমার স্ফেরিক্যাল হারমোনিক্স সব ডিরাইভ করতে হবে 100 পর্যন্ত, বুঝছো? এল এর ভ্যালু 100 পর্যন্ত তোমার সব লাগুয়ার, সরি, কি লজন পলিনোমিয়ালস বের করতে হবে। হ্যাঁ, এক্স্যাক্টলি, সরি বলে দ্যাট ওয়াজ আ জোক। হ্যাঁ, স্ফেরিক্যাল হারমোনিক্স পর্যন্ত থাকবে। তাহলে একটু দেখি আমরা লেকচার নোটটা, লাস্ট লেকচার নোটটা। সো লাস্ট লেকচার নোটে আমরা হচ্ছে গিয়ে, হ্যাঁ, স্ফেরিক্যাল হারমোনিক্স এর থেকে কোশ্চেন আসবে। দ্যাটস গুড, হ্যাঁ, বাট স্ফেরিক্যাল হারমোনিক্স থেকে যে কোয়েশ্চেন আসবে, মানে তোমরা কনসেপচুয়ালি বুঝলেই কোয়েশ্চেনটা মোটামুটি মানে আনসার করতে পারবো। হ্যাঁ, যে স্ফেরিক্যাল হারমোনিক্স থেকে ধরো যে আমি এরকম, এই যে এটা যেমন যে এটা ডিরাইভ করা, রাইট? স্ফেরিক্যাল হারমোনিক্স কি, এটা করা, এইটা হ্যান ত্যান এইসব করা, এগুলি করবো না। হ্যাঁ, এগুলি এই যে এরকম হ্যান ত্যান, ওইসব করবো না, হ্যাঁ, কোনো কিছু মুখস্থ করতে হবে না, রাইট? সো আই ডোন্ট লাইক পিপল, I cannot memorize anything. I don't like people. I don't want to make people memorize anything. Okay. Okay. Any other questions? Final is going to be very easy. So there's no reason to relax, no reason to panic. I want you to, for quantum mechanics, I want you to finish the assignments that are still out there. Don't worry too much about the final, okay? আমার কথা হচ্ছে কি, if you have done the assignments, you have come to class, you have done the quizzes, and you remember something from quantum one, which is of course a big key assumption, then final is going to be very easy. Yeah, of course. Well, there I won't give proofs from the uncertainty principle, but there will be a question. So তোমার হয়তো আমি তোমাকে অপারেটর দিয়ে দিব, তোমার এখান থেকে হারমোনিক তোমার সরি আনসার্টেনিটি প্রিন্সিপল কমপ্লিট করতে হবে, রাইট? দ্যাটস ইট. So you have to know the steps, right? Uncertainty principle question complete করতে কি করতে হয়. What is delta x, for example? Delta x is defined in terms of delta x squared, right? You have to know that, right? So those stuff like that, right? তোমাকে যদি এখন আমার পরীক্ষার মধ্যে variance এর definition শিখাইতে হয়, then that's not going to be good, right? Okay. Any other questions? Okay. I mean, let's just quickly look at the other lectures. So lecture 4. Okay, so lecture 4 was basically just about Dirac notation, so that's not a big deal. This is also about the Dirac notation. Okay. It's really lecture 1, 2, and 5. 1, 2, 3, and 5. So this is harmonic oscillator. Good, good, good. So this is, of course, very important. As is number 1, which is also harmonic oscillator. And also, yeah, so these are the two different ways. And then also the Heisenberg picture, okay? So, all right, I think this is good. Any other questions or? Okay, so in that case, let's end the meeting. Is that okay? Okay, তাহলে হ্যাঁ, good luck. হ্যাঁ,
স্যার আমার
হ্যাঁ।
সিওকে দেখছি আমি আমি দুটো মিস করেছি বাট হচ্ছে
তুমি আমার সাথে ওইটা নিয়ে আলাদা যোগাযোগ করো।
স্যার আমার কি হচ্ছে কুইজ এর সময় কি আমি লেখা কুইজ দিতে পারবে কিন্তু আমাকে
তুমি আমাকে বললাম না, তুমি আমাকে ইমেল করো। এটা আমি টেলিং ইউ টু আমি প্রত্যেক না, I don't want to deal with the whole class asking for a makeup quiz. প্রত্যেকের কেস আমার আলাদা হবে। I don't want people to I don't want, আমার এটা খুবই অসুবিধা হয় এই যে 3-4 জন সবসময় ক্লাসে থাকে যারা কুইজ দেয় না, তারপর তারা মেকআপ কুইজের জন্য করে। the idea of giving more, মানে আমি একটা কুইজ বাদ দেওয়ার মানে হচ্ছে গিয়ে তুমি একটা কুইজ, কোনো একটা কুইজ মিস করলে তুমি অন্য কুইজ দিয়ে ওটা মেকআপ করতে পারবে, রাইট? সো দ্যাটস দ্য হোল আইডিয়া। এবং কিন্তু ওই যে কেউ যদি অ্যাসাইনমেন্ট ডেডলাইন মিস করে, কেউ যদি কুইজ মিস করে, তাদের প্রত্যেকের জন্য আলাদা 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 টাইম দিতে দিতে আর আমার কোনো টাইমই থাকে না। হ্যাঁ, ওইটা হ্যান্ডেল করতে খুবই অসুবিধা হয়। ওকে, সো ইমেল। হ্যাঁ, n-1 এর জন্য প্রথম থেকে বলে আসতেছি।
ওকে স্যার, ঠিক আছে, থ্যাংক ইউ।
Okay. বাংলাদেশে যেমন -2, এখন তো -3 হওয়ার মতো অবস্থা মনে হয়। যাই হোক, ওকে তাহলে, হ্যাঁ, এনি আদার কোয়েশ্চেন্স? Okay, I will post this in a moment.